Why does electrical grounding matter so much in industrial plants? Imagine a world where machines spring to life with a mere touch, where every interaction with a device propels you into a dance with danger, where the very air you breathe crackles with static electricity. That's the chaotic realm you'd inhabit without the unsung hero of electrical safety grounding. Grounding, or earthing, is the process of creating a direct low-resistance path for electric current to flow into the earth in the event of a fault or surge. It's the silent guardian that protects both people and equipment from electrical faults, ensuring that the industrial world keeps turning safely. There are three primary grounding techniques used in industrial plants: solid grounding, resistance grounding, and reactance grounding. Solid grounding, the most common technique, connects the system directly to the ground. No resistance, no reactance, just a straight shot to the earth. This simplicity is its strength, providing a clear path for fault currents and allowing protective devices to quickly clear faults. However, this technique can also lead to high fault current levels, which can damage equipment and create a potential safety hazard. Next up is resistance grounding, which introduces a resistor between the system and the ground. This technique limits the fault current, reducing the risk of equipment damage and improving safety, but it's not perfect. The resistor can heat up during a fault, leading to potential failure, and the lower fault current can make it more difficult for protective devices to detect and clear faults. Last but not least, we have reactance grounding. This technique uses a reactor instead of a resistor to limit fault current. The reactor adds an inductive element which can provide additional protection against transient overvoltages. But just like the other techniques, reactance grounding has its drawbacks. The inductive element can create a resonance condition, potentially leading to higher fault current levels and more severe equipment damage. Each of these grounding techniques plays a critical role in industrial safety, and each has its strengths and weaknesses. Solid grounding offers simplicity and fast fault clearance, but can lead to high fault current levels. Resistance grounding provides fault current limitation and improved safety, but can struggle with heat during faults and detection of lower fault currents. Reactance grounding adds an inductive element for additional protection, but can risk resonance conditions and more severe faults. So the next time you flip a switch or press a button in an industrial plant, spare a thought for the silent guardian of electrical safety grounding. It's the invisible force that keeps us safe and the unsung hero that keeps the industrial world turning. And remember, while each grounding technique has its place, the best choice will always depend on the specific requirements of your system. So choose wisely and keep the lights on safely.